Part 2 of today's video is on relations and functions. If you watch the video on coordinate plane, you should be able to identify the following points. So why don't you go ahead and pause the video and identify what those 5 points would look like as ordered pairs. When you are finished, resume the video. Okay, hopefully you've identified each of those points by their ordered pairs. I'm just going to start here on the left. If I look at this point right here, 1, 2, 3, -4 on the x-axis, and please remember that our x value always goes first. 1, 2, 3 on our y-axis. So that is the point -4, 3. This one below, -1, -2, -3 on the x-axis, and -1, -2 on the y-axis. This point is actually on the y-axis. Points that are on the y-axis actually have an x value of 0. And then when we count up 1, 2, we would identify this point with the ordered pair 0, 2. This point should have been 2, 1, and finally 1, 2, 3, 1, 2, 3, 4, -5. Now what we're going to do is we're going to use those 5 points to introduce you to what it means to be a relation and what it means to be a function. First of all, a relation is any set of ordered pairs. So if we look at those 5 ordered pairs that we've graphed, we can simply list them and identify them as a relation. And that's exactly what I've done in the example. 0, 2, -4, 3, -3, -2, 2, 1, and 3, -5. That is a relation because it is a set of ordered pairs. Within our relation, we can break it up by our value for x, which we refer to as the domain. So all the first coordinates are our x coordinates. Those coordinates are the input number and are referred to as the input independent variable. And what we want to do is simply list 0, -4, -3, 2, and 3. Those 5 values, where we look at our values for x, represent the members of the domain. And again, those are the independent variable. The range, those are the second coordinates within an ordered pair, or our y values. And that is the output number, or the dependent variable. So if I want to list the numbers in the range, I simply look at the values for y. 2, 3, -2, 1, and -5. Again, I just looked at my values for y. So as you can see, it's not very hard to identify the domain and range. And what we can do is we can take that domain and range and we can picture them 2 ways. The first way we can picture them is in a table. And all we will do is make a table with 2 columns. And the left column will be the numbers within our domain. Let me remind you of what those were. 0, -4, -3, 2, and 3. 0, -4, -3, 2, and 3. And then we can do the same thing with the range. Those would go in the right column. 2, 3, -2, 1, -5. Sorry, let me look at those again. 2, 3, -2, 1, and -5. The second way we can do it is through a map, where again, we take those numbers in the domain and we put them within a small oval on the right. And then we're going to put the numbers in the range on the left. And simply in a map, what we do is we associate one member of the domain with its range. So if you remember, we had the ordered pair 0, 2. Well, we map it with 0 as our domain, 2 as a range, and an arrow going from one to the other. If you remember, -4 was a pair with 3. -3, -2 was an ordered pair. 2, 1 was an ordered pair. And 3, -5 was also our ordered pair. So we have two ways for us to show what our ordered pairs could look like in terms of domain and range. That takes us to a function. Remember, we said that a relation was any set of ordered pairs. Well, in a function, there's a specific relationship between the input and output in which there is always exactly one output for each input. So one of the things that you're going to come to recognize is that relations and functions are very, very similar. Now, please note, all functions are relations. So all functions represent a group of ordered pairs. However, not all relations are functions. And what I'd like to talk about now is, how do we know? So I've got two examples here. The relation 0, 1, 1, 2, 2, 3, 3, 4 is a function, but the relation 0, 1, 0, 2, 0, 3, and 0, 4 is not a function. They are both relations, but only one is a function. And that goes back to our definition, where exactly one output for each input. As you can see, in the first relation, 0 is being paired with 1. 1 is being paired with 2. 2 is being paired with 3. And 3 is being paired with 4. So each member of the domain is paired with exactly one member of the range. In our second function, however, 0 is paired not with one number, but with 4 numbers. And that violates our definition of a function. 0 is not paired with exactly one output. It's paired with 4 different outputs. So that is why, although it is a relation, it is not a function. Now, I would like for you to identify, out of those two, which one is not a function. Hopefully, you could quickly identify that the first one is not a function, but the second one is a function. And again, remember your definition of a function. That will allow you to see that 1, in this case, is being paired with 1, 2, 3, 4, and 5. It is being paired with 5 different numbers. That violates our definition of a function. So there's obviously a trick here. What we need to do is look at our x value. If any of our x values repeat themselves, then we would say that that relation is not a function. Now, what if you are trying to identify whether or not a relation that has been graphed is a function? For example, I've got two graphs here. They both represent relations, but both of them are not functions. Can you identify them correctly? One of them is a function, one of them is not. Which one? Hopefully, you identified the first as a function and the second not a function. we do that so easily? Well, we can use our vertical line test. Our vertical line test tells us whether or not that relation is a function. And what we do is we draw a vertical line through our graph. And if that vertical line only touches one point, then we know that it is a function. If we draw a vertical line and it passes through more than one point, then we know that it is not a function. Now, please be careful. When you draw your straight line, your vertical line, you want to make sure you aim for the middle of the graph, or aim for a point where there possibly could be more than one point. As you see on the left, it does not matter where we draw that vertical line. It's still only going to pass through one point. But if we're not careful with the one on the right, we may think that it is a function because we drew our vertical line in the wrong place. Now it's your turn. For homework tonight, I want you to look at page 52 in your textbook and complete questions numbers 20 through 32. And then when you come to the library tomorrow, please bring those questions with you. Good luck.